This is the third and last segment of video for Chapter 9 in the McGraw-Hill text. And really, we just have one more thing to cover. There are a few loose ends that are on the last screen, but ionic equations. So an ionic equation, really any equation that has ionic compounds in it can qualify for being an ionic equation. We're going to deal with double replacement because it's the one that has all of the parts except for one is going to be split into its ions. And this way you can learn one and it'll be easier for you to perform on the quiz and the test. Later on we can go into some a little more complicated, maybe single replacement or some others that also can be stated as ionic equations. What is an ionic equation? Well, ions are where ionic compounds split into their parts. When an ionic compound is put into water, it is ripped apart by water. The negative ends, the oxygens in water, grab the plus part, and the H's, which are the positive end, grab the negative part. And they somewhat pull those apart, and they exist out there in their ionic form. So everything that is aqueous is dissolved in that way. Now, the reaction we did in lab that y'all may remember produced that yellow precipitate. That's the one that we're working with up here. We've actually put that same equation up here on the board. And that one we are going to work the net ionic and complete ionic equations. So on your review, you'll notice that the last question asks you to take this equation, or an equation, it's a different one, and write the complete ionic equation, the net ionic equation, and then mark the spectators. That's what we're going to do here. It should prepare you for the test, because on the test there will be an open free response question just like that. So, first item of business, always balance equations. This one's not balanced. You need to balance it. Hopefully you'll balance that on your lab also. We have two iodines here and one there. So we need to put a 2 in front of the Ki, and that gives us 2 Ks. So we put a 2 in front of the KNO3 on the other side. That gives us 2 NO3s, and we go over here, we already have NO3 too. So now we're balanced. So the second item of business, find the up arrow, the down arrow, or the G. And the up arrow and G are both gas. The down arrow is precipitate. In this case, we have a down arrow which indicates that PbI2 is a precipitate. That one part isn't going to change. It's going to precipitate to the bottom, sits on the bottom, and it doesn't dissolve into the water. So we're going to rewrite it here, PbI2, and we're going to rewrite it down here, PbI2, because it's going to be in the net and the complete ionic equation. How do we make the ionic equation? You split all the parts into their ions except for the part that has the up arrow or down arrow, or the G. So, after the first cap, after the first cap, after the first cap, that tells you how they split. What are their charges? Well, this one has a 2 here, and the 2 came from the Pb. This one has a 1. The 1 came from the 1 minus on NO3. If you look at your polyatomic ion chart, it tells you the charges of all your polyatomic ions. And you'll have that for a test. K is in 1A. Roman numeral 1 says 1 plus. I, remember over at the end, the noble gases are 0. The next column, the halogens, are all minus 1. That's a minus 1. This is a plus 1. That's why it's 1 and 1. K, again, plus 1. NO3 minus. The PbI2 doesn't split. Remember, that dropped to the bottom. So to do the complete ionic equation, now all we've got to do is just write the ions. So Pb, 2 plus, aqueous, because it's dissolved and it's being held by water, plus NO3, 1 minus, but there's 2 of them because it's NO3, 2. We put a coefficient in front. No longer have subnumbers on ions, only coefficients. So 2 NO3 aqueous plus 2K plus aqueous plus 2I minus aqueous yields K plus aqueous. There are two of them because there's 2KNO3 plus 2NO3, NO3 1 minus aqueous plus PbI2 down arrow. It is a precipitate. So that is our complete ionic equation. We just take all the parts that aren't an up arrow or down arrow or a gas, split them, and write the charges. The net ionic equation is the equation that shows how the product with the up arrow, down arrow, or gas is produced. So in this case, we have a precipitate, PbI2. How do we make PbI2? We put Pb, 2 plus, that's aqueous, and I2, I minus, that's aqueous, into the solution in the form of lead nitrate and potassium iodide. So when we drop those in, they like to switch partners in this case because the iodine has more of an attraction towards the lead 2 plus. They stick together and drop to the bottom as a yellow precipitate. This is called the net ionic equation. So that's how we write those three parts. Final thing is to identify the spectators. Anything not in the PbI2 in this case, anything that's not the up arrow or down arrow or gas, in this case it's a down arrow precipitate, would be the K and the NO3. And the NO3 and the K, they don't change. They're the same on the left as they are on the right. They're just spectators. So it's kind of like going to a football game. The main show's down on the field, the band, the cheerleaders, the dance teams, all that, the football players, and the spectators just kind of hanging out up there having a good time. And they don't change. Beginning of the game, they're sitting. End of the game, they're sitting. Same things with these spectators. So go through those. Look for some practice problems like that. If you have problems, make sure you do the one on the review because it's very close to what you're going to see on the free response question on the test. So the last page is kind of more stuff, just the final shots across the bow here. I told you I would give you a couple more synthesis that were compound plus compound because you're going to have one that's going to, these are a little tougher. So I'm going to give you these two, plus you have two on your practice pages, and you have a couple of them in your chapter, and I think one in the notes yesterday. I'm going to pick from those 5 or 6. One of those will be on the test. Make a flashcard with all of them, and it's just a matter of looking over it. But remember, we went over some specific ways that you know how to put those together. So practice those, get your review done, come in for tutorials, and good luck.